welcome back once again to More Math. Last time we talked, we were talking about rates. Today we're going to expand on that a little bit and we're going to talk about unit rates. A unit rate. If I have a unit, that means I have one. And that is the beauty of a unit rate. We're going to talk about a rate that has a 1 in the bottom because that lets us compare things. Last time I told you about my plug-in hybrid car, which I love because I never buy gas and I often brag about this. And at this point, when I checked my odometer before I came in, my trip mileage, it said that I'd gone 688 miles and so far I'd used 4 gallons of gas. Well, that's nice, but it doesn't really let you compare very well. How we're going to compare this is by finding the unit rate. In other words, the unit rate means I want a 1 on the bottom. This is what makes a unit rate a 1 on the bottom. How do we do that? Just like we had learned before, we're going to divide these. We're going to take the top divided by the bottom. How do we turn a fraction into a decimal? How do we find a unit rate? We take the top divided by the bottom. We're going to take 688 divided by 4, throw that in my little calculator, and I came up with 172 miles. My board's a little wobbly today. All right, so my unit rate for my car right now, because it changes all the time, I can go 172 miles on 1 gallon of gas. Ask your mom or dad or uncle or grandpa. They're going to be pretty impressed. That's pretty good. Most cars, when you go to buy a car, you might get 24 miles per gallon, you might get 33 miles per gallon. These are all unit rates. So when people buy a car, they like to compare. Well, how much gas mileage do I get? That's one of the things we compare. With electric cars and plug-ins, you get really good gas mileage. All right, so fully electric doesn't use gas at all, but that's a whole nother story. Anyway, this is our first example of a unit rate, and I want to write this down here with a nice bright color. And I hope that you have a piece of paper or maybe a notebook where you take notes and stuff. We're going to say that 1 means this is the unit rate because there is a 1 on the bottom. All right? One situation where we use unit rates a lot is when we go grocery shopping. Before, I think I told you, this is the math that's going to save you money. If we can learn to do this well, we can make our money go farther than it would before. For example, I'm going to go buy some cereal. And if I want to buy some cereal, let's say that box of cereal is going to cost me $3.98. And that box of cereal has 11.4 ounces. Another box of cereal I could buy has $4.98, but it has 15.6 ounces. Which one's the better buy? Is the bigger box always the better buy? It usually is, but not always. How do we find out? We're going to find the unit rate. You guys, it's really easy. To find the unit rate, the cue, the clue, the idea that you want to remember is we're going to put money over stuff. So when I go shopping, I'm going to say, how much for the small box of cereal? The small box of cereal is $3.98. I like to label it because I want to keep track of what unit I have where, of what quantity I have where. I have money on the top. So it's money on the top over my stuff. Over what? 11.4 ounces. So I'm going to put 11.4 ounces right here. Okay, if I grab my calculator and I do the math, what do I come up with? That tells me that I'm buying that box of cereal for 35 cents for 1 ounce. Do you see what I did there? I took the top divided by the bottom, I took $3.98. I divided it by 11.4. What does that tell me? That tells me that 35 cents per 1 ounce. Now I can find out how much other cereals cost, and I can compare. Are they about the same? Is this one more? Is the generic better? We can find out. In this case, I bought the same brand of cereal. So the other one was $4.98. So we're going to do that. $4.98 divided by 15.6. I'm going to grab my calculator and I put it in. How do I put it in? Top divided by the bottom. You got it. Once I do that, I found out this box of cereal was 32 cents for 1 ounce. So which one is the better deal? This one is, of course, right? Because the small box costs 35 cents an ounce, but the bigger box costs 32 cents an ounce. But wait, sometimes we get a coupon, like maybe in the mail, a coupon's going to come in. And if the coupon comes in, maybe it says, this is 50 cents off. Make this pen work right. We're going to take off 50 cents for the small box. Well, now if we take off 50 cents, how much is the small box of cereal? The small box of cereal becomes $3.98 minus 50. It becomes $3.48, right? All right, so if it's $3.48, we're still going to divide it by the 11.4 ounces. And what do you think we get now? Well, I'll tell you. It's going to come out to 30.5. In other words, it's going to average, it's going to round up to 31 cents per ounce. So now with that 50% off coupon, the small box is actually cheaper. And they do that sometimes. Sometimes they issue coupons only good on the 11.4 ounce size. They do that. That comes out like that. So by doing the math, I found out that for this, when I have the coupon, I actually want to buy the small box. Not what I expected. Let's try another example. Let's talk hot sauce. You might say it's a really hot topic. Kind of tasty. I wouldn't say it. I don't like hot sauce. But my husband does, so we buy a lot of hot sauce. So he went and bought some for me, and he bought it in 2 different sizes. Obviously the large size, $7.68 for the 12 ounce, and the small size, $3.82 for the 5 ounce. Which one is a better buy? And is it a big difference? Like, maybe the difference is so small, it's not worth buying the big one if it's just going to sit on the shelf for a couple years, right? Sometimes we have to think about that. Is the saving worth it? Well, let's find out what the difference is. Again, I'm going to write it so that I have the money over the stuff. In this case, it's money over ounces. Money always goes on top. So when you're thinking about unit rate, if you're talking about money, money goes on top. You might have a really weird situation where the money's on the bottom. That could happen, right? But that's really unusual. When I'm comparing prices and I want to know which one's the cheapest though, money's going to go on top. How many dollars per ounce? How many dollars per box? How many dollars per carton? Okay? All right, so let's do the math. I grab my calculator, I put in $7.63, and I divide that by 12 ounces. Can you do that in your calculator? I believe in you. I hope you're doing this on your own piece of paper. That would be phenomenal. All right, what did it come out to? I believe that came out to 64 cents. Is that what you got? We got 0.64 cents, so that's 64 cents per ounce. Now, I don't think I said this before, and I need to. This little line here, how do we read that? We say the word per. Not purr like a kitten. Per like P-E-R. Per. All right, so it's 64 cents per ounce. Okay, that doesn't seem too bad. What about this one? If we put $3.82 and divide that by 5, how much is that per ounce? Well, that comes out to 76 cents an ounce per ounce. I want to talk about a couple of things real quick. All right, the smaller one is over 10 cents an ounce more. That's actually quite a bit. If you use hot sauce at all, the big one is definitely a better buy. Notice that I wrote on the bottom here, I just wrote ounce. I didn't write a 1. Is that okay? It is okay. If you remember from another lesson, every whole number, like if I have the number here 0.76 and I just write the number, there's a ninja 1 underneath it. Every whole number has a 1 hiding underneath. So without ever writing it, I know that that's true. It's talking about how much of a whole. So I don't have to put a 1, okay? You'll notice that as I did my math, I have labels here. I have a dollar sign here, and I have the word ounce here. Why do I do that? Because I want to keep it straight. I know this may surprise you, but I make mistakes. Matter of fact, sometimes I make a lot of mistakes. So by writing down my units, it helps me keep track, and then I don't make as many mistakes. When I'm all done, I say this out loud. I say 64 cents per ounce. Yep, that's the way I wanted it to go. Because if I would say 0.64 ounces per dollar, well, that's not how we talk about things. We talk about money per ounce, right? So we can hear it and we can see it. We can make sure that we did the math the right way. If the units come out right, you guys, you probably did the math right. It's really hard to get it wrong if you get the units right. So always want to write down those units. Really helpful. Let's talk about Sally. She's doing her math homework. We are very proud. Yay, Sally. And Sally took 30 minutes to work 20 problems. Not bad. Not bad at all. What I want to know is how many minutes did she spend on each problem? As soon as you hear me say the word on each problem, each one means that's the one that's going to be the 1. That's going to be on the bottom. In other words, I want to know when I'm all done how many minutes she spent on each problem. Does that make sense? As soon as I hear the word each is a clue word, and that clue word tells me that that's the quantity on the bottom. How many minutes did she spend on each problem? Problem goes on the bottom. Okay, now remember we just said if we do our units right, we're going to get the problem right, most likely. And so we, I think, did our units right. We said we want to know how many minutes per problem. Well, how many minutes total did she spend? She spent 30 minutes. How many problems did she work? She spent 20. Do you see how easy that was to set up? So often we're afraid of story problems, but now we're getting a little older and we're getting a little stronger in our reading skills and our math skills, and hopefully we're understanding what we're trying to solve for. It makes it a lot easier if you know what you're looking for, right? So in this case, how many minutes per problem? So the minutes are on top, the problems are on the bottom. Here we go. What is 30 divided by 20? Well, they both end in 0, so I can divide the top by 10 and the bottom by 10. Once I do that, I can just knock off the 0. 30 divided by 10 is 3. 20 divided by 10 is 2. So we've reduced this fraction to 3 over 2. What is 3 divided by 2? It's 1.5. She spent 1.5 minutes on each problem. Do you see how we did that? Unit rate problems let us compare. Let's say someone else spent 45 minutes on 30 problems. We could do the same math and we could compare and say who spent more time on the problems. That's how we compare. We do the unit rate. I really like unit rates. I feel like they help me to compare things really well. Hey, you know what? Fetch told me that he was going to go grocery shopping. Let's go swing by his place and see if he made some good choices. Let's go. Hey, we're back at Fetch's house again. And look, I tricked you a little bit. Fetch is actually the one that went shopping, and he bought 2 boxes of cereal and some hot sauce and stuff, and he let me use his receipt to do the comparisons that we did over there. That was pretty nice of him. Here's a summary of what we talked about. We said if we bought the really big box of cereal for 15.6 ounces, we spent 32 cents an ounce. But if we bought the small one, we spent 35 cents an ounce. But since Fetch had a coupon for the small box for 50 cents off, he only spent 31 cents an ounce. That's hard to say, cents an ounce. You try it. Anyway, it actually wound up being a little bit cheaper than the big box. Fetch does a good job when he goes grocery shopping. He uses his unit rates to make sure that he's getting the best deal. I hope you do the same. When you go shopping with mom or dad or uncle or somebody, take your calculator, take the total cost, divide it by the ounces, and see how much it costs per ounce. And you can help make great decisions to save money when you go grocery shopping. I'm so proud of you. I'm proud of you for watching this video and taking an interest in your education and doing what you can to make great decisions. Good job! I look forward to seeing you next time. Bye!